As humans, we obviously communicate with each other. We do that in a number of ways, like speaking, text, and so on. But we also do that in a number of languages. In today's more global world, having the ability to quickly and efficiently analyze and process what our users are saying is critical. And that's where natural language processing, or NLP, comes in. NLP is an area of AI that deals with understanding written and spoken language. There are a number of different models that Azure deploys to achieve that. Statistical models can be used to determine the probability of what someone is saying. Machine learning models can be used to apply those probabilities to further train models. And deep learning models can be used to further dive into more complex scenarios and derive their meaning. So, just what is natural language processing anyway? Well, NLP breaks down into a few areas of capability. For example, NLP combines computational linguistics modeling of human language to try to capture the actual meaning or intent of human language. For example, you can say something like, "Please turn off my lamp," and NLP will understand that your intent is to power down a lamp entity. NLP also enables computers and apps to process real human speech and text. And that's important when you think about calling a business versus texting support. Another capability of NLP is that it allows computers and apps to interpret the sentiment behind human language. Imagine a hotel review. Was it a positive or negative review? NLP is able to look at the chosen words and their arrangement to determine an overall score of someone's sentiment. All right, so NLP sounds pretty interesting. We use it for? Well, there's quite a lot of applications for NLP. For example, as we already talked about, with NLP you can perform processing of any sort of text as well as speech. Speech processing can be in real time or performed in a batch offline situation. NLP can also be used to perform morphological analysis of any given text and speech. And this can be used to break down a sentence into meaningful parts. For example, inflection can be removed, tense, and so on. Syntactic analysis can also be done by NLP, and that means being able to find the boundaries of a sentence, figuring out the grammar, and parsing a sentence into its logical pieces. And NLP can also be used for figuring out lexical semantics. And what that means is, put overly simply, deriving the meaning of words within the context of a sentence. For example, the sentence, "I didn't say he stole the money," has completely different meanings based on which word carries the emphasis. For example, I didn't say he stole the money. 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 I didn't say he stole the money, and so on. Next, you can also use NLP to determine relational semantics. Relational semantics are about identifying relationships between entities in a sentence. For example, who's married to whom? And finally, NLP can be used to process discourse, meaning outside the bounds of a single sentence, what's being talked about? What's the overall mood of a conversation? What's the context here? All right, so NLP seems to be capable of doing lots of cool things, but why use it? How can NLP help in the real world? Well, one big advantage of NLP is that it can be used to analyze text, any text. Give it some online user reviews or maybe even emails or texts from users, and then parse that text to figure out what the key words and overall sentiment of that text is. Does the user want anything? Is there something we can learn from the feedback? And so on. And while NLP can do all that for text, it can also do the same things with spoken language too. NLP can interpret what is being actually said by a person, dictate it, and then perform all the same analysis that it would do in text. And it can do that in real time or offline after the fact. One other really useful feature of NLP is that it can translate between languages too, and not just text, but also speech. So imagine a scenario where a user calls a hotline, gives their feedback in any language, and then that feedback is converted to text and translated to English for processing at headquarters. And finally, because NLP can process intent and entities from sentences, it means that NLP is ideal for interpreting user commands. Our homes are getting smarter. Being able to say things like turn off the lamp and having your house just listen to you and perform the command is all thanks to NLP. Now, NLP is very clearly something that's easy to wrap our heads around from a written text perspective. You and I can look at a written sentence and figure out what it's saying. But when it comes to speech, that's a whole other ballgame. Now, I've already mentioned that NLP can process spoken sentences, but what else can it do with speech exactly? Well, obviously, the main thing NLP can do is speech recognition. NLP can determine what words are being said and then convert that to text. Plus, it can figure out likely punctuation. A period makes a huge difference in word processing, doesn't it? Anyway, once the words are in text, then standard NLP processing can take place. NLP can also perform speech tagging. And what that means is that it can process individual words differently based on grammar, context, and so on. Tagging can help determine the nouns, verbs, and so on. And finally, with NLP, you can perform word sense disambiguation. What that means is that NLP can determine the meaning of a word based on how it's used in a sentence. Did you know that the word set has 430 definitions in the Oxford Dictionary? So, which version was meant when it was spoken by a user? Well, that's where the word sense feature comes in. Now, NLP isn't a new concept. The roots are in the 1950s. Alan Turing famously proposed the Turing Test, wherein he opined that a sufficiently defined AI would be indistinguishable from a human. Symbolic NLP was the first real go at natural language processing. The idea was that, given a collection of rules, a computer could emulate natural language understanding by applying those rules. This was worked on from the 50s to the early 90s, but you can imagine how complicated and verbose those rules would be, and they'd be changing all the time. In the 90s to the 2010s, statistical NLP was the new strategy. This is when machine learning algorithms started to come into being. The idea here was to implement the machine learning to determine the statistical likelihood of meaning behind given text. And the most recent strategy is neural NLP. Neural NLP stands on the shoulders of machine learning and implements deep learning to model, predict, and parse natural language. The difference is fairly noticeable when we talk to AI online. There are less formulaic, robotic, and cold responses, but rather a human element to the conversation. So, what else can NLP do? Well, NLP is pretty powerful. Its ability to decompose and understand text and speech can help us do lots of different things with messages that we receive. For example, NLP can easily perform named entity recognition. That means it can easily parse a sentence and determine which entities are in that sentence and which ones are important. NLP could be able to hear something like, I met my friend Alice in Paris, and determine that the key entities are Alice and Paris. Another useful feature of NLP is what's called co-reference resolution. That means it can determine if there are multiple references to the same entity in a single sentence. For example, NLP would be able to hear something like, Bob is so tall he has to duck when coming through doorways, and then determine that Bob and he are referring to the same entity. Sentiment analysis can't be understated either. Being able to process a sentence, a paragraph, or more, and being able to gauge the mood as leaning towards positive or negative is pretty useful. And finally, the ultimate feature is that NLP can be used to talk back. It's not just about parsing information it's given, but also about being able to return speech or text in natural language form as well. Azure's Natural Language Processing, or NLP, is able to determine what any given piece of text means by performing various kinds of text analysis. For example, one of the things text analysis can do is what's called part of speech tagging. What that means is that, given a sentence, various words can be tagged as referring to a certain part of speech. For example, imagine the word book. In the sentence, the book is on the table, book is a noun. Meanwhile, in the sentence, I'm going to book a flight, book is a verb. So, depending on the nature of the sentence, each word can be tagged as having a particular meaning in that sentence. Text analysis can also perform morphological segmentation. What that means is that certain words can be morphed into different variations, but still mean the same thing. Like close, closes, closed, and closing are all separate words, but are really the same word with slightly different contextual meaning. Another thing text analysis can do is lemmatization. Lemmatization removes inflection from words, so you're left with the base word. Now, this is slightly different than morphological segmentation because a word like better actually has a root of good. And finally, we have stemming. Stemming is usually done before lemmatization. This brings certain words down to their base form. So, for example, imagine the sentence, Alice betters herself. Well, betters is stemmed to better, and then the word better becomes good as a result of lemmatization. The main purpose of NLP is to understand text. Text isn't always as simple as I like chocolate. Sentences with formulaic subjects, predicates, and objects, or nouns and verbs, are just not a natural way of speaking. So, the purpose of NLP is to take that natural language and break it down so that we can understand what's actually trying to be said. For example, one thing we can do when we analyze a sentence is try to figure out what sort of relationships exist. For example, if someone said, Bob is married to Alice, then that would be a sentence that indicates a relationship between two entities in that sentence. In this case, the relationship type is marriage, but it could just as easily be something else. Semantic parsing is a way that we can convert a sentence from natural language to a logical form. For example, if you said something like, Please show me all the flights from LA to New York, semantic parsing would break that down into something like list flights and then a to and a from. Now, NLP can also determine the meaning from text by applying semantic role labeling. And what that means is that various parts of the sentence are broken down into roles. For example, imagine the sentence, Bob sold the book to Alice. In that sentence, Bob is given the role of agent. The word sold is considered the predicate, and the book is the theme, and the recipient is Alice. Natural language translation is not a new concept. We've been attempting to automatically determine the underlying intent and meaning of written language since the 1950s. The first attempt at that was using symbolic NLP. But symbolic NLP was not without challenges. The main issue is that it was rules-based, and that meant translating text was enormously complex. Language is so rich, diverse, and full of slang and sayings and cultural references that it's virtually impossible to create a catalog of rules for one language, never mind translation between them. For example, in English, the sentence, I didn't say he stole the money, has completely different meanings depending on which word has the emphasis. Then try conveying that meaning in another language. After symbolic NLP was mostly abandoned in the early 90s, the world shifted towards statistical NLP. Statistical NLP came into the spotlight as a result of machine learning algorithm revolutions in the field. With a continuous increase in compute power and availability, along with the advances in linguistic understanding, statistical NLP attempted to solve the NLP problem by basically determining meaning and intent based on statistical probability. But this too wasn't without its challenges. For example, statistical models were enormously complex. As was learned from symbolic NLP, getting rules was extremely difficult, so training models with supervised learning wasn't quite practical. That meant training models using unsupervised learning, which is more complex and less accurate. Another challenge was with regards to textual corpora. So, for example, in Canada, official documentation generated by the federal government must be presented in both official languages of English and French. And that meant that statistical NLP could take advantage of these types of documents to understand the same text, but in multiple languages. However, the availability of textual corpora was, and is, extremely limited. Nevertheless, natural language processing continues to be considered a field of great value. There are some intuitive uses for NLP that can make our lives much easier. For example, consider semantic-based searching. When you're searching for something in some online store, it's always annoying to search for things by very specific keywords. And it's even more annoying if the spelling and tense matters. For example, let's say you wanted to search for information about kayaking. Well, it'd be super annoying to get different results if you put in the word kayak versus kayaking. Semantic-based searching can help determine the meaning of what you're looking for and give back appropriate results. Customer feedback analysis is another great use case for NLP. Imagine wanting to search for a good restaurant in a city that you're traveling to. Well, with NLP, thousands of customer reviews in multiple different languages can be reviewed to give you an idea of what people really think about various restaurants. The analysis can not only tell you if the reviews are positive, but also which restaurants had good service, were clean, had good food, or were romantic. Of course, we can't talk about NLP without dreaming of digital assistants. With AI, the ideal would be to have users call or message a system and then be able to interact with that user. The AI would be able to understand the user from their natural speech patterns or written text, understand what they're talking about, and then respond just as naturally. Now, natural language processing isn't just a pipe dream, it's really being used. In fact, some of the biggest companies in the world are already using NLP in everyday tools that you're probably already using. For example, a common implementation of NLP is spam detection. That text from a suspicious email can be parsed and quarantined if it's considered to be spam. It's an interesting use case because spam can be identified by what it's selling, but also by virtue of it being badly formed. For example, there's a 50% off sale on books right now, act now. That would trigger spam detection, but so would books cheap, you buy now. Machine translation is also another common implementation of NLP. Google Translate is probably the single most common implementation of this capability of NLP. And while we talk about the dream of AI driven virtual assistants and chatbots, they really are here. AI is very commonplace when it comes to online support. It's still fairly obvious when you're talking to AI, but it's nevertheless coming along. Social media sentiment analysis is also another implementation of NLP that companies are implementing quite a lot. This allows companies to gather insights on trends based on online reviews, responses, opinions, and general commentary. And finally, NLP is being used to digest huge amounts of digital text and creating summaries and indexes. In fact, there are vast amounts of data entry jobs that will be replaced by AI in the future. And some say this even includes lawyers looking up case law. Natural language processing is a form of AI, and as a result of that, the workload features of Azure NLP is very similar to that of any other form of AI. For example, NLP has all of the same common AI workload capabilities, and that means that it still requires input data and training. Then it can still be scored, tested, deployed, and improved upon as we learn more and more. So the model can be taught, then sent out into the wild, where it can learn more by virtue of having more exposure to input data and feedback. Of course, because NLP is a form of AI, that means that it still needs to adhere to the various principles for responsible AI. In fact, because one feature of NLP is to be able to speak back to a human and give information and guidance, it's all the more important that NLP doesn't take advantage of that position of influence and betray our trust. Azure has a number of tools that can be used to manage your NLP workloads. Now, obviously, the bulk of the work is still done in Azure's ML Studio, and from there you can create pipelines, models, experiments, and so on. Plus, you can use tools like notebooks to interact with language APIs. But there are also other peripheral tools. For example, configuring natural language understanding is done through an external Microsoft service that allows you to train models on intent and entities and then publish that to the world. It sounds and is very similar to work you'd do in ML Studio, but this service is organized explicitly for language understanding, so it's more intuitive. And of course, Azure includes a whole host of different language processing resources. And these can all be installed individually, or they can be installed in a single bundle as part of what Azure refers to as cognitive services. In fact, let's dig into some of these individual resources. One Azure resource that you can use for language processing is called Text Analytics. Text Analytics is capable of analyzing any given text or phrase and then determines the various components of that text. For example, imagine an online review site for hotels. Users from all over the world would be traveling and visiting various hotels and then leaving their feedback about those hotels. Then one day you're planning to travel and want to pick a hotel with good reviews and qualities that you like. Well, with text analytics, reviews can be parsed and certain information can be determined about them. And this includes things like language, because users can be from all over the world, key phrases like good service, clean rooms, and so on, key entities like locations and dates, and even the overall sentiment towards each hotel. Text Analytics is a resource that you can deploy in Azure, and then an API is made available that you can use to gain all of those insights into various text or phrases. Another Azure resource that you can use for language processing is called Translate Text. Now, this might shock you, but that resource is used to, well, translate text. But it's actually more interesting than that. The Translate Text feature allows you to take any given text and translate it from whatever language it is to just about any other language. In fact, Azure supports 60 different languages. And it's not just the Latin alphabet either. You can translate from English to Chinese, or Spanish to French, or even Japanese to specifically Canadian. One of the things I like about this feature is that it's not just straight word translation, but rather intent translation. So punctuation can actually make a huge difference in what's being translated. And then comes Azure's Language Understanding Service. Language understanding is installed as a resource in Azure that lets you use an external service to train internal models to understand commands that the service might receive. There are two ways commands might be received: spoken commands and textual commands. The language understanding service lets you configure entities and intents. For example, imagine the sentence, switch off the light. In that sentence, the intent is switch off, and the entity is the light. Now imagine that sentence, turn off the lamp. Well, you and I as humans know that those two sentences are the same. While with language understanding, you can train the underlying model to understand that lamp is a synonym for light, and that turn off is another way to say switch off. Then the model can learn from there so that it can understand similar commands like turn off the lantern. One more Azure resource that you can use for language processing is called Speech. The Speech resource is used for two main purposes: to recognize and synthesize speech, and translate spoken languages. The idea behind the speech service is to be able to do all the same natural language processing that can be done with text, but with spoken language. And that makes sense. Users are going to talk to virtual assistants or issue commands to their smart home devices like Alexa or Google. That feedback or those spoken commands are recognized and synthesized and then processed like regular text. But as I said, one of the cool features is the translation. And that means that users can give their feedback in a phone message, for example, in any language that they speak, and then that feedback can be translated to a common language so that it can be sent for review at headquarters. When natural language processing is performed on any given text, phrase, or speech, there are several bits of information that's extracted. But one key thing that's done is called key phrase extraction. But what does that mean? Well, put simply, given some kind of natural language text, key phrase extraction can extract one or more meaningful phrases. And it's important to understand what is meant by a key phrase. For example, a key phrase is usually a single word. It is usually the most important entity in the entire sentence. A key phrase could also be a compound noun. It's like a single word but made up of multiple words. For example, Christmas tree or swimming pool. And of course, that means that a key phrase could also be a modifier plus a noun. For example, a striped cat or deep sea. The classic Azure ML Studio includes a module called Extract Key Phrases from Text. And this module can be used in pipelines to analyze data from any given dataset of text and then extract the key bits of information. For example, as we talked about, you can use the module to connect to a dataset and specifically extract key phrases from the text. When you use the module, you actually have to connect it to a dataset that has text in it. Specifically, that means using a tabular dataset. And once the text module is connected to the dataset, you need to select which specific column has the text in it. And of course, in order to parse that text, the module needs to know what language that text is in. So you can configure the module to tell it what language to use. But what if there are multiple languages in the dataset? Well, in that case, the dataset itself should include information about what language each row is in. And in that case, you can configure the module to look at a different column for language information. Now, if you're not using the classic Azure ML Studio, you can actually perform key phrase extraction using Azure's Text Analysis Resource API. So while language processing can be used to extract key phrases, it can also be used to recognize entities. But what's an entity? Well, an entity is basically a common identifiable thing. For example, an entity could be a person, a company, or even a location. But really, an entity is any tangible thing that a sentence is referencing. So for example, when we look at that sentence like turn off the lamp, we would actually say that the lamp is the entity. The classic Azure ML Studio also includes a module called Named Entity Recognition. Now this module can be used in pipelines to analyze text from any given dataset of text and then figure out what the entities are. So for example, as we just talked about, you can use the module to connect to a dataset and specifically extract entities from that text. Now when you use the module, you actually have to connect it to a dataset that has text in it. And specifically that means, again, using a tabular dataset. Once the text module is connected to the dataset, you need to select which specific column has the text in it. And this is usually referred to as a story. But the key part here is that this module needs a dataset. If you're not using the classic Azure ML Studio, you can perform entity recognition using Azure's Text Analysis Resource API. The new API is more real-time, and you can pass text to the API and get immediate responses. But with this module and the classic ML Studio, you need to provide a dataset. Now, while language processing can be used to extract key phrases and entities, it can also be used to recognize intent. But what's intent? Well, intent is an action that you want to take against one or more entities. Put another way, the intent is the intended result of a behavior. So if we take our example from earlier when I said turn off the lamp, we know that the entity is the lamp, but the intent is to turn it off. Using Azure's Language Understanding Service, you can train models to understand entities and intents so that you can work towards creating a model that will understand user commands from text or speech. Think about home assistants like Alexa or Google. Their job is to listen for your commands and execute those commands. Whenever you give a command, they'll try to decipher your intent, the action that you want to take against an entity, the thing. They do that using natural language processing. And finally, we get to sentiment. Determining sentiment from text can be very valuable. Imagine a hotel review. In that review, a user has given a certain amount of feedback about the hotel. Certainly, it might have key phrases, entities, and intents in it that can be used to improve a facility. It could have phrases like clean rooms, friendly staff, and traffic noise, and those are all handy. But what's the overall mood of the text? And that's the sentiment. Is the review largely positive or negative? With sentiment analysis, companies can get user reactions for important aspects of their business. For example, a social media sentiment analysis can tell a business how people feel about their brand online. Some people simply won't buy products because they don't feel a brand has good quality. Understanding that sentiment can help a business work on changing that perception. Sentiment analysis can also tell a business how people feel about a specific product. EA suffered quite a bit with product feedback in the recent past, and this forced them to change how they deploy in-game purchases. Of course, individual messages can also be parsed for sentiment. You can receive emails or online messages and automatically parse them to see if the feedback you're getting is largely positive or negative. Now, by using sentiment analysis, you can determine what the overall opinion of the user base is about your offering. It also gives you your own opinion on how you feel about that feedback and how it should affect your company. For example, if the feedback is largely positive, but it's really then you might work to improve that further. In this demo, we're going to train a language model based on text commands in Microsoft's Language Understanding application. To do that, we're going to set up a Language Understanding cognitive service in Azure and then use Microsoft's Language Understanding service to create entities and intents, and then train a model. Now, before we get started, we need to make sure that we have the Language Understanding resource installed in Azure. So let's do that. First, we need to head over to the Azure portal. Now, to add an Azure resource, let's click on the Create a Resource link in the hamburger menu in the top left corner. Now we need to search for Language Understanding in the search field at the top of the news screen. Now let's click on the Language Understanding box and click Create. Good. Now we can select a resource group. Obviously, you can create a resource group on the fly or select an already existing one. In my case, I'm going to use the same resource group that my machine learning workspace is in, because that will make it a lot easier for me to clean up when I'm done. So I'm going to select my SB Test resource group. Good. Now let's give our resource a name. I'm going to call mine SB Test CSLU. The CS stands for Cognitive Services, which is what this resource really is. Now for the authoring and prediction resources, it wants us to select a location and a pricing tier. Now I'm just going to select a close location and then choose the free tiers since this is a demo. And now I can finally click Review and Create, and then Create. Good. Now our language understanding resource is ready to go, but now we need to configure a language understanding app. To do that, we need to go over to Microsoft's Language Understanding service in another browser tab. So let's head over to that tab. Now to access this app, you need to go to luis.ai. Now I've already done that here. If you've never been there before, you'll need to click on Login and log in with your Azure account. Now if you've never logged into this service before, it might prompt you for some information about which resource that we've just created. If that happens, go ahead and select the resource that we've just created. Then, once you're logged in, you're presented with this screen which lists all of your conversation apps. So let's go ahead and create one. We can do that by clicking on the New App button in the toolbar at the top of the screen. In the pop-up, we need to give our app a name. Now I'm going to call mine SBTest CSLU app. And then in the Prediction Resource field, I'll select the language understanding resource that we just created in the Azure portal. And then we'll click Done. Good. Now this takes us to the app view. Now what we want to do here is we want to create some entities and intents to help train a model. So let's go ahead and start by creating entities. In the left-hand menu, there's an option called Entities, so let's click on that. Now entities are a thing that a language model can identify and do something with. So now let's create an entity. To do that, we'll click on the Create button in the toolbar. Now let's name our entity Device. And then we'll select the List Type Radio button. And then we'll click Create. Good. Now this takes us to the details page about our new entity. Now a device is a thing, but there are lots of types of devices. So let's give an example. We can do that by typing in the normalized value column. So let's go ahead and add a value of light. But there are synonyms for light, aren't there? Some people call it a lamp. So let's add a synonym for light by typing lamp into the synonym field. Good. Now let's repeat this process to create another type of device called fan with a synonym of AC. All right, so now we have an entity called device which has two known examples of fan and light. Now we want to configure some intents. An intent is an action that you want to take against one or more entities. So let's go to the intents configuration screen by clicking on the intents option in the left-hand menu. Now let's create an intent by clicking on the Create button in the toolbar. And now let's name our intent switch_on. Good. Now this takes us to the details page about our new intent. This details screen asks us for an example of user input that would correspond to this intent. So our intent here is to create something called switch on. So let's create an example of what might trigger this intent. Now to do that, we can type into the example user input field in the center of the screen. Let's give an example of turn the light on. Now notice that this put our text underneath the field and underlined the word light and suggested that it's a device. Yes, our entity. If that were to be wrong, we could change it by clicking on the word light. Now let's create another example with the text turn the fan on. And now let's make sure that the word fan is a device. Good. Now let's go over this process again, but for a new intent called switch_off. Excellent. So now we have an entity and a couple of intents. Now we can start training our model. To do that, we can click on the Train button at the top right corner of the app. Now this takes our information and trains a language model behind the scenes. We don't have a lot of stuff in here, so it doesn't take very long. And once it's done, we can test our model by clicking on the Test button beside the Train button. Now this opens up a panel on the right that we can then give utterances to. An utterance is effectively a command from a user. So let's try a few commands. First, let's try switch the light on. It determined correctly that the intent is the switch on intent. Now let's try turn off the fan. Now that command also correctly determined that the intent was the switch off intent. Now let's try one of our synonyms. Let's try turn the lamp off. And once again, it's determined the correct intent. Now let's be a little silly and try extinguish the illumination. In this case, it doesn't understand our entity nor our intent. So we can see that our model isn't perfect. But it would not be great to have to define every possible word. So let's try something not so outlandish. Let's try turn the lantern off. In this case, it understood the correct intent. All right, so now we have some intents and we have an entity. Now, obviously, we can keep adding to the list with things that we know and understand, but we can also see that things that are reasonably close to what we've defined will work. So if we're happy with our model, we could publish it and make it available to the outside world. To do that, all we'd have to do is click on the Publish button in the top right of the page. Once the app is published, external sources like ML Studio's notebooks can be used to interact with the app to determine the intent of certain user-given commands and even train the model further. Now, for the sake of this demo, we won't bother publishing the app. We've already proven that we can create an application and train a language model to understand entities and intents. In this demo, we're going to explore text analytics results from some hotel reviews in Azure ML Studio. To do that, we're going to use the Text Analytics Cognitive Service to run through a sample Microsoft notebook. Now, as we execute the sample, we'll explore and understand what each aspect of the analysis results mean. Now, before we get started, we need to make sure that we have the Text Analytics resource installed in Azure and then get a couple of bits of information from there. So let's do that. First, we need to head over to the Azure portal. Now, to add an Azure resource, let's click on the Create a Resource link in the hamburger menu in the top left corner. Now we need to search for Text Analytics in the search field at the top of the new screen. Now let's click on the Text Analytics box, and then click Create. Good. Now let's give our resource a name. I'm going to call mine SB Test CSTA. The CS stands for Cognitive Service, which is what this resource really is. Now you can select whichever subscription and location you want, and I'm going to leave mine as the defaults. As for the pricing tier, well, since this is a demo, I'm going to just select the free option. And now we can select a resource group. Now obviously we can create a resource group on the fly or select an existing one. In my case, I'm going to use the same resource group as my machine learning workspace because that'll make it a lot easier for me to clean up when I'm done. So I'm going to select my SB Test resource group. And now I can finally click Create. Good, now our text analytics resource is ready to go, but we'll need a couple of bits of information from there. So let's go to the resource and get them. We can do that by clicking on the Go to Resource button at the center of the screen. Good. Now, like most Azure resources, in order to use this resource, we need to have an endpoint and a key. We're going to need that later, so let's get that information now. We can get those bits of information from the keys and endpoint blade, so let's click on that. Alright, so now this screen shows us two keys, an endpoint and a location. What we need from this screen is one of the keys and the endpoint. So let's copy one of the key values and the endpoint value over to Notepad. So now we have a text analytics resource and the connection information. Now let's actually do some text analysis. To do that, we need to head over to our ML Studio. Now I've already got mine open in another tab, so I'm just going to switch to that tab. Good. Now what we want to do here is run through a Microsoft sample that already includes some text for analysis. We want to take that text and push it through our fancy new text analytics resource and have it pump out some information about what it sees in that text. Then we can explore that information and make some decisions about that text. To run the Microsoft sample, we need to head over to the Notebooks section. Now before we go any further, this demo assumes that you've already configured a compute instance in ML Studio. If you haven't, you'll need to go ahead and do that first. We don't need a particularly hefty compute instance. A simple D11 v2 VM will do the trick. Anyway, what we want to do now is download the Microsoft sample for text analytics. To do that, we're going to execute a git command to clone the sample locally. To do that, we need to first create a file so that we can execute the git command. So let's go ahead and create a file by clicking on the Create New File button in the Notebooks toolbar. Now in the pop-up, let's give the file a name. In fact, we'll keep it simple and call it git commands. Then I'll set the type as notebook and click Create. Good, now this opens up the new file automatically, and that's good because we want to issue a command. But before we can do that, we need to make sure that we've got our compute instance selected. You can do that by selecting your compute instance in the toolbar for the file. Mine is already selected, so I'm good to go. Alright, so what we want to do now is execute a git command that will clone a Microsoft sample into our local notebook. So to do that, I'm going to paste the command into the rectangle selection in the middle of the screen. Now I'll provide that command in the doobly-doo so you can copy it from there. Good. Now we can execute the command by clicking on the play button on the left of the command. Now below the command, we can see the output for the command. Once the command has been fully executed, we can click on the refresh button in the notebook toolbar and see a new folder called AI Fundamentals. Good. So let's expand the AI Fundamentals folder. Good, now what we can see in this folder is that there's all kinds of different activities that you can do in here. In our case, we're interested in text analytics. So let's click on the 02A text analytics file. Now, the Microsoft sample on text analytics includes a lot of useful information and guidance. It's really worth reading over the information in this file. But in the interest of time, I'm going to run through this relatively quickly and then explain what's happening. So let's scroll down to the first code block. Now, what this code block does is collect a set of user reviews about hotels, and the reviews are contained in the sample. But it could just as easily be a database that you have where users are putting in their thoughts. Anyways, let's go ahead and click the play button to the left of the code block. Excellent. So below the code, we can now see 4 reviews. Just a cursory glance of the reviews tells us that there's a mix of good and bad reviews in there. So what we want to do now is actually analyze the text in these reviews. It's all well and good to visually analyze 4 reviews, but if it was 4,000 reviews, well, that'd be a bit harder. So we want to make sure that we've got some automation going on here. Now that means connecting this notebook to our text analytics resource that we created earlier. So if we scroll down to the next code block, you'll see that we now need to populate a couple of variables with our key and endpoint that we collected earlier. So let's populate the key variable with our key and the endpoint variable with our endpoint. And then run the code block. Excellent. Now this notebook requires modules to be able to run Azure's text analytics service. So let's scroll down to the next code block and run the installation command. Okay, so at this point, we now have the entire system prepared to actually do some text analytics. Finally, now let's scroll down to the next code block. This code block executes a piece of code called detect language. Unsurprisingly, it detects the language of each of the reviews that we collected earlier. Then, for each review, it will score its confidence in selecting that language. So let's go ahead and execute the code block and see what it tells us. So we already knew from looking at the reviews that they were all in English, and it would appear that the language detection agrees with us and is very confident in that selection since it's given every review a score of 1.0. Good, now let's scroll down to the next code block. This code block executes a piece of code called key phrases. This code looks at the text in each review and figures out what the key text is. It does this by eliminating some fluffy text and joiner text. Actually, let's just run it and see. As you can see from the output, the key phrases we're left with are things like locations, objects, short descriptions that could be opinions, and so on. So now let's scroll down to the next code block. This code block executes a piece of code called sentiment. Basically, what this code block is doing is looking at each review and deciding if it's a positive or negative review. It does this by scoring the text in the review. A negative review would have a score of less than 0.5 or 50%, and a positive review would have a score higher than that. So let's run this code and see what it says. So here we see 2 positive reviews and 2 negative reviews. Based on the scoring, the first review is 99% positive, and the second review is so negative it needed an exponent. The third review is again overwhelmingly positive, and then the last review is once again ridiculously negative. Boy, these people either love or hate these places. Now finally, let's scroll down to the last code block. This code block executes a piece of code called entities. Entities are basically common identifiable things, and they can be people, places, or dates. So if the reviews contain anything like that, this command will find them. So let's go ahead and execute this code block. And sure enough, there are the entities. We see locations along with Wikipedia links, dates, and other items that could be locations or dates. And that's it. That's text analysis. One of the key cognitive services that Azure includes for natural language processing is the text translator service. The text translator service is used to, well, translate text. And it has loads of features in it. So let's dig into that a little bit. With the text translator service, applications can integrate translation. That means that users of an application can enter information in one language and have it be stored or displayed in other languages. And this can be particularly useful if you have knowledge base articles and a globally available app. Now, as of now, the text translator service supports 60 languages, including all of the most common languages like English, French, German, Italian, Chinese, Japanese, and so on. So the chances are really good that whatever language you want to translate your text to is supported. Now, the text translator service can also translate any given text to another language and output the result as text. But if it's integrated with the speech service, then spoken words can be converted to text and translated to another language as well. Great, so the translation feature sounds wonderful and exciting. So, how do we use it? Well, to use the translation capabilities of Azure, you actually have to deploy a resource. And there are two ways that you can deploy language resources. The first way is to deploy the individual services that you want to use. For example, if you just want to translate text, then you can deploy the text translator resource in Azure. But if you also want to decompose speech, then you can deploy the speech resource. Both of these resources can give you specific keys and endpoints that you can use to interact with them. But if you don't want to manage individual resources like that, then Azure includes a resource called Cognitive Services, which bundles all the various cognitive resources into one. So this includes the various natural language processing resources, as well as visual processing, anomaly detection, and so on. Now, using the text translator service is fairly straightforward. Once you've deployed the resource, you're given an endpoint and keys, and you can use the key to connect to the endpoint and issue commands to the text translator API. Now, this is really good because it means that you can perform translation on the fly. Of course, there's also other benefits to the service being accessed via an API. For example, when the API is called, it forces a set of rules on the consumer. The values must go into certain parameters, the content must be formatted a certain way, and the language codes must follow international standards. Specifically, the API makes consumers provide language codes that conform to the ISO 639-1 standard. And of course, because the service is accessed via an API, it means that consumers, like applications, can perform many simultaneous transactions all at once. Now, for the most part, the text translator service is a black box. You can feed it information, and it gives back the translated text as desired. But that doesn't mean the service can't be configured or tuned to your liking. In fact, there are lots of options you can pass to the API when you're requesting translation. For example, one thing you can do is configure filtering on profanity. By default, the service will take no action. But if you want to filter profanity, you can have the choice of simply marking profane words or removing them from the response altogether. Another thing you can do is what's called selective translation. And what that means is that you can tag some of the text you're asking to be translated and ask for it not to be translated. For example, imagine you have text like, "Example app is a Great Times award-winning service and a must-have for your business." In that case, the terms example app and Great Times are brand names or titles, and so translating them wouldn't make very much sense. So you could mark those terms and tell the translator to translate everything else but them. Of course, translation isn't just about translating text. With the Azure Speech resource installed, you can also translate spoken words to another language too. And this process isn't technically easy to do, but it is pretty easy to explain. Specifically, the speech resource can recognize spoken words and dictate them into text, and that includes all the necessary determination of likely punctuation, versus just one big long string of unbroken text. Now, it's also worth noting that the speech resource can also be used to convert text back to speech. And so what that means is that the speech translation is actually achieved by converting the spoken words to text, using the underlying text translator to perform the translation to another language, and then converting the result text back to speech. See? Pretty simple, right? I'm sure it didn't take a developer more than a day to build this. So what are some ways that we can deploy and implement Azure's speech and translator services? Well, there's lots of ways that it can be deployed. In fact, I'm sure you can think of a few yourself. But some of the most common uses are real-time translation from one language to another, and remember that there's up to 60 other languages that you can convert to, translating a speech simultaneously to multiple other languages. And of course, simultaneous two-way translation between two different language speakers. In fact, I used features like this while in Japan. It was enormously useful to be able to talk with locals and understand each other. Of course, sometimes if the translation is just slightly off, it can make for... In this demo, we're going to explore translating written text in Azure ML Studio. To do that, we're going to use the Text Translator Cognitive Service to run through a sample Microsoft notebook. As we execute the sample, we'll explore and understand what the service is actually doing. Now, before we get started, we need to make sure that we have the text translator resource installed in Azure, and then get a few bits of key information from there. So let's do that. First, we need to head over to the Azure portal. Now, to add an Azure resource, let's click on the Create a Resource link in the hamburger menu in the top left corner. Now we need to search for Text Translator. Now let's click the Translator box and click Create. Good. Now you can select whichever subscription you want, and I'm going to leave mine as the default. And then we can select a resource group. Obviously, you can create a resource group on the fly or select an existing one. In my case, I'm going to use the same resource group as my machine learning workspace because that'll make it a lot easier for me to clean up when I'm done. So I'm going to select my SB test resource group. Then we have to select a region. I'm going to choose the region at the top of this list since it's temporary. Now let's give our resource a name. I'm going to call mine SBTest CSTT, and the CS once again stands for Cognitive Service, which is what this service really is. And as for the pricing tier, well, since this is a demo, I'm going to select the free option. And now we can finally create it. Good, now our text translator service is ready to go. But we'll need a few bits of information from there. So let's go into the resource to get them. We can do that by clicking on the Go to Resource button in the center of the screen. Now, like most Azure resources, in order to use it, we need to have an endpoint, a key, and the region. We're going to need that later, so let's get that information now. We can get these bits of information from the Keys and Endpoints blade, so let's click on that. Alright, so this screen shows us two keys, an endpoint, and a location. What we need from this screen is one of the keys, the endpoint, and the location. So let's copy all those values over to Notepad. So now we have a text translator resource and the connection information. Now let's actually do some translation. To do that, we need to head over to our ML Studio. Now I've already got mine open in another tab, so I'm just going to switch over to that tab. Good. Now what we want to do here is run through a Microsoft sample that has the code that we can use to translate text to different languages. We want to be able to even give some of our own text and push it through our fancy new text translator resource and have it pump out text in another language. Now to run the Microsoft sample, we need to head over to the Notebooks section. Now before we go any further, this demo assumes that you've already run our text analysis demo from earlier, and so you've already configured a compute instance and you've cloned Microsoft's AI Fundamentals Git repository. If you haven't done that, you'll need to go back and do that. So let's expand the AI Fundamentals folder. Looks like it already is. Now we can see in this folder that there's all kinds of different activities that you can do in here. In our case, we're interested in translation. So let's click on the 02C translation file. Now the Microsoft sample on translation includes lots of useful information and guidance, and it's worth reading over that information in this file. But in the interest of time, I'm going to run through this relatively quickly and then explain what's happening. So let's scroll down to the first code block. Now this code block is asking us for information about our text translator resource that we just created. Now in order to perform the actual translation task, this notebook requires access to our translator resource. And that means that we have to populate this section with our details that we copied into Notepad. So let's go ahead and copy the key to the key variable, the endpoint to the endpoint variable, and the location to the region variable. Then we can run the code block by clicking on the play button to the left of the code block. Great. So at this point, we have the entire system prepared to actually do some translation. Now we can scroll down to the next code block. This code block creates a function called translate text. This function calls a Microsoft Translation API and passes in the text to translate along with information about what language it is and what language we want it to be translated to. Then at the bottom of the code block on line 32, we can call that function. In the call, we pass in a piece of text from line 30 and ask to translate it from French to English. So let's execute this code block and see what happens. Perfect. Hello became bonjour. But what if we want to change the text from hello to hello, my name is Sven? Well, let's find out. Now the output is bonjour, je m'appelle Sven. But what about other languages? Well, let's scroll down to the next code block to see. This code block executes the same code as before, only it's now translating from British English to Italian. So let's execute this and see what we get. All right, hello becomes ciao. That sounds right. Okay, That's great that we can translate text from one Latin alphabet to another, but what about logographic languages like Chinese? Well, let's scroll down to the next code block to see. This code block is once again executing the same code that we've used in the previous two blocks, except this time we're translating the text from US English to Chinese. So let's execute this and see what we get. Whoa, look at that! We gave it hello and it responded with the correct ni hao. And that's it. That's text translation. In this demo, we're going to explore translating spoken words to text in another language in Azure ML Studio. To do that, we're going to use the Speech Cognitive Service to run through a sample Microsoft notebook. As we execute the sample, we'll explore and understand what the service actually does. Now, before we get started, we need to make sure that we have the speech resource installed in Azure, and that we get a few bits of key information from there. So let's do that. First, we need to head over to the Azure portal. Now, to add an Azure resource, let's click on the Create a Resource link in the hamburger menu in the top left corner. Now we need to search for speech in the search field. Now let's click on the speech block and create. Good. Now let's give our resource a name. I'm going to call mine SBTest CSS. Now you can select whichever subscription and location you want, but I'm going to leave mine as the default. Now as for the pricing tier, well, since this is a demo, I'm going to select the free option. And then we can finally select a resource group. Now obviously again, you can create a resource group on the fly or select an already existing one. In my case, I'm going to use the same resource group as my machine learning workspace so that I can clean up a lot easier when I'm done. So I'm going to select my SB test resource group. And now I can finally click create. Good. Now our speech resource is ready to go, but we'll need a few bits of information from there. So let's go into the resource to get them. Now we can do that by clicking on the Go to Resource button in the center of the screen. Good. Now, like with most Azure resources, in order to use the resource, we need to have an endpoint, a key, and the region. Now, we're going to need that later, so let's get that information now. Now, we can get those bits of information from the Keys and Endpoints blade, so let's click on that. Alright, so now this screen shows us two keys, an endpoint, and a location. What we need from this screen is one of the keys, the endpoint, and the location. So let's copy that information over to Notepad. So now we have a speech resource and the connection information. Now let's actually do some translation from spoken word. To do that, we need to head over to our ML Studio. Now I've already got mine open in another tab, so I'm just going to switch over to that tab. Good. Now what we want to do here is run through a Microsoft sample that has code that we can use to translate speech to different languages in text form. We want to be able to take some recorded speech and push it through our fancy new speech resource and have it pump out the text version of that speech in another language. To run the Microsoft sample, we need to head over to the Notebooks section. Now before we go any further, this demo assumes that you've already run our text analysis demo from earlier in this course, and that you've already configured a compute instance and you've cloned Microsoft's AI Fundamentals Git repository. If you haven't done that, you'll need to go back and do that. So let's expand the AI Fundamentals folder. Looks like it's already expanded. And now we can see in this folder that there's all kinds of different activities that you can do in here. In our case, we're interested in translation, so let's click on the 02C translation file. Now the Microsoft sample on translation includes lots of useful information and guidance, and again, it's worth reading over that information in this file. But in the interest of time, I'm once again going to run through this relatively quickly and explain what's happening. So let's scroll down to the first code block. This code block is asking us for information about either a speech resource or a text translator resource. Now technically this sample is capable of doing both. And if we'd installed a cognitive service resource instead of a specific speech resource, then we could enter its details here and all the code blocks in this sample would work fine. But since we've installed the resources separately, we have to be a bit careful here. Anyway, this notebook requires access to our speech resource, so that means that we have to populate this section with our details that we copied into Notepad. So let's go ahead and copy the key to the key variable, the endpoint to the endpoint variable, and the location to the region variable. Then we can run the code block by clicking the play button to the left of the code. So at this point, we have the entire system prepared to actually do some translation from speech to text. Now let's scroll all the way down to the first code block in the section called Speech Translation. Now this code block shows that we need to install an Azure Speech module into ML Studio so that we can execute the code that we need to execute. So let's go ahead and install the module by running the code block. Perfect. Now let's scroll to the next code block. This code block creates a function called Translate Speech. Put simply, this function accepts a sound file and attempts to convert the speech in the audio file to text from the language specified in the language desired. Then, at the bottom of the code block on line 43, we call that function. In the call, we pass in a sound file called english.wave from line 41 and ask it to translate it to Spanish. So let's execute this code block and see what happens.
Hello.
Perfect. We can hear that the file said hello, but we can also see from the text beside the player that the sound was translated to hola. Okay, so that's great that this works with hello, but what about other speech? Well, let's change the file by using something else. I happen to know there's another sound file in another folder, so I'm going to change the file name value on line 41 to lightoff.wave. And the folders on line 42 to data and speech. Good. Now let's execute that.
Turn the light off.
Awesome. So now the sound file is different and we can see that the text translation has worked as well. We see the English version, which means it properly picked up the text from the file, and we see the translated version to Spanish. But it doesn't just translate from English either. We can pass in speech from other languages and have it translate to English. So let's do that. Let's scroll down to the next code block. This code block executes the same code as before, only now it's translating a file that's in French to English. So let's execute this and see what we get.
Bonjour.
Perfect. It took the terribly pronounced French and converted it to English. And that's it. That's speech translation. So in this course, we've worked with the Azure Natural Language Processing services to handle language modeling for text-to-speech, speech-to-text, and translation. We did this by exploring natural language processing, its uses and challenges, features of Azure NLP services, handling phrase extraction, entity recognition, and intents in NLP. We also trained a language model. We explored Azure Translator service features and uses, and used the Translator service to translate text and speech. In our next course, we'll create an Azure ML conversation bot service that uses a knowledge base to answer